Bienvenidos, Ushamdeed, and welcome to this Hut 8 Consulting networking techtorial on Cisco's Enterprise Networking, Security, and Automation course, or ENSA, which is part of the new Cisco CCNA version 7 curriculum. In this techtorial, we're going to be focusing on Packet Tracer Activity 6.5.6, where we're going to be configuring Dynamic NAT. So let's go ahead and take a look at what the activity is asking us to do. This is a very straightforward activity, and I like it because it doesn't give us the answers to the activity. In other words, we're going to need to know how to perform this configuration work. You can see that the majority of the work, and in fact, I believe all of the work, is actually going to be here on router 2. So let's dive in here. We're going to configure an ACL. Now, Dynamic NAT, remember, you can have multiple inside local IP addresses, right? And we're going to be dealing with two subnets here, and we're actually going to be creating an ACL right now that's going to allow the 172.16.0.0/16 network to be translated. So those inside local addresses will be available for translation to an inside global address. And in this case, our inside globals are going to be these 209.165.200s, and I'm going to talk a little bit about how this address space is actually going to work, because this is one of the more confusing topics for learners once they get into configuring Dynamic NAT. So, step one, again, straightforward, and this is why Cisco covered access control lists prior to covering NAT, because we need to know how to do the ACLs in order to configure NAT. And so we're going to configure a single access control entry for this single ACL. And again, the ACL number is going to be 1. So we've got a standard ACL in which we can only match on the source network or device. And in this case, that works perfect because we're trying to match the source networks on the inside of our enterprise network here. Now, let's go ahead and say access list 1, and we're going to permit 172.16.0.0. Now, what is our wildcard mask going to be for a /16? Well, remember, if it's a /16, what they're saying is that the first 16 bits are being used for the network. So in other words, it would be 255.255 and dotted decimal notation with a subnet mask here, .0.0. Whoops, terrible zero there. .0.0. And so that would be the subnet mask. Well, if we subtract this from the all 255s, I'll just put some lines up here representing 255. And if I was to subtract this, I'd get 0.0.255.255. And remember, the wildcard mask is the inverse, and I'll say WM, wildcard mask is the inverse of the subnet mask. And you can see that right here. Because if we've got a 0 here, it's a 255 here. 0 here, 255 here. It's the inverse of the subnet mask. All right, so that kind of sorts that component out for us with respect to our netmask in the ACL 0.0.255.255. So there's my ACL. You can see down here in the lower right hand corner, if you're following along for the completion percentage, you can see that it's increasing down there. Now, the ACL is typically the easiest of the configuration steps when dealing with Dynamic NAT. And remember, when we're talking about Dynamic NAT, sort of think of it as this is the outside and this is the inside. In other words, this is inside my network. This is outside my network. This is, you could think of this as like, and that's a terrible A there, an autonomous system boundary router. Now, this may be a term you're probably not familiar with, but if you deal with OSPF or BGP for that matter, this is a term you're going to see often. And just means autonomous system. This is kind of like, this is our autonomous system, and this is all the stuff inside my network. And here's kind of like the D mark. It's like halfway through router 2, because once we get out here, we're outside of our autonomous system. And this would be the boundary between the inside network and the outside network. So new term there that you're definitely going to be using in your networking career. And so now let's go ahead and take a look at what we're being asked to do next. And again, this is probably going to be a little more difficult here when you're trying to set this up initially. So the first thing we have to do, it says configure R2 with a NAT pool. Now it does not dictate the name that we have to use for the NAT pool. So I'll keep it simple, and I'm just going to call it NAT, right? And so we're going to configure a NAT pool that uses 2 addresses in that range of addresses. And this is critical because this 209.165.200, if .228 is what would typically be referred to as the network ID when we're doing subnetting, right? And we know a /30 has 2 usables, .229 and .230. Whoops, sorry, that's 0. For some reason, it's not letting me draw zeros. 0, and then our broadcast address is going to be 231. So I'll just say broadcast address, and this would be, and again, this is when we're talking about traditional subnetting, this would be my network ID, or the subnet ID, and I'll put an S in here, so it's either S or N, subnet or network ID. And we've got our 2 usable, I'll just put a U here, for usable IP addresses, right? Now remember that in classic subnetting, if I was using this subnet for an interface on a router, this would be the set of rules I'd be dealing with. I'd have 1 network ID, subnet ID, 2 usable IPs, and the broadcast address. And that's kind of how we've been talking about subnetting up until right now. So it wants me to use 2 addresses in this address space range. Now, this activity is not going to give you points by saying 228 and 229. And it's not going to give you points if you say 230 and 231. The only way we're going to get credit, and it's kind of how they've got it set up here, is to use 229 and 230 as the 2 addresses in that range. And so here's how we say IP NAT, here's how we create the NAT pool, right? The pool of addresses that are going to be made available for translation to the hosts that qualify based on this ACL that we've configured. So anybody in the 172.16.0.0/16 network is eligible for translation. This is the pool of inside global addresses that could be used. All right, so we say IP NAT pool, and then again, if I do a question mark, you can see it's just going to be the name of the pool. I'm going to call it, we'll just call it NAT, and maybe we'll say pool. NAT underscore pool. That way it's just not NAT. Now, when I say 209.165.200, now this is where it's going to be tricky because they want us to pick 2 addresses in the range. And remember, how this works internally with the router is the router, when I enter this command, is going to do a subnetting exercise based off the information I've put in. And if, for whatever reason, the range of addresses that I've put in are not self-contained in the subnet that I've identified, right, a /30, if these 2 addresses would not be in the same /30, we're going to get an error. And so I already told you 229, and now you can see here it wants the ending address. Well, that's going to be 209.165.200.230. Now, here's where we put the Netmask. Now, typically I make the mistake, as if you do a question mark, you can see it says Netmask. And so a lot of learners will think, oh, okay, well, this is where I do the 255, 255, 255, 252. Well, it's not. You're going to get an error there because you have to actually put, Netmask, not network. You have to put the keyword Netmask followed by the Netmask. And so if I do a question mark here, you can see that that's the command. So we're at 20% now. When I hit enter, we're actually going to be getting some more points. We're now up to 45%. And so what I've said here is that those two addresses, 209.165.200.229 and 230, are the only two available IPs to be used as inside global addresses for translation. Now, what if I would have said this? And this is where it gets confusing for a lot of learners. What if I would have put, and what are we looking for? 228. Excuse me. What if I would have put this? Because this contains both the subnet ID and the broadcast address. But again, remember, when we talk about NAT, we're not specifically talking about broadcast addresses and subnet IDs in terms of that would be the use of those IPs. We're talking about using these inside global IPs for translation. And so this command is a legitimate command, and it's going to give us, and let me copy that real quickly, that would give us the use of 4 IP addresses. And so where learners become confused is they say, oh, well, you can't use the 228 and you can't use the 231. If that was the statement I used right here, then we would only use 2 of the addresses, the 2 usable addresses, 229 and 230. That is not the case with NAT, right? So let's jump to a real router here as a quick segue. I want to show you this. I'm going to leave that drawing information there. And let's go into global config. And there's that IP NAT pool command. And when I hit enter, you can see all of those addresses, 228, 229, 230, and 231, legitimately sit in this /30 range. And so iOS, when I hit enter right there, did a quick check and said, hey, would those 4 addresses be in this subnet range? And the answer is yes. Let's rerun that command. And what would happen if I said 220, and let's actually won't do 224. Let's drop it to 192. I'll say 192, and actually we'll change one more thing here just to make sure we don't run into anything unexpected. And so if I said 192, and we'll go to 254, and I made the subnet mask instead of /30, let's make it a /29, and we'll go to 248. Right? So now the question is, in a 248, we've got 6 usable, 8 total, but how many IPs am I specifying here? I'm specifying well over, 56 IPs or something like that? So, or I'm sorry, 8, 54, like 64. So when I hit enter, take a look at what the iOS check does for us. It comes up and it tells me that that subnet mask is too small. It has to be at least 255, 255, 255, 192. And again, start and end addresses for that pool are in different subnets. And so again, remember on real iOS, you would get an error if for whatever reason the range of inside globals, right, those 209 publicly routable IPs that we're looking to use for translation on the outside, if we have too large of a range when compared to our subnet mask length. So iOS is very good here at catching any mistakes that might pop up when you're doing that configuration. But the takeaway here, right? The key takeaway is if I was to say 228 to 231, this is a pool now of 4 NAT translatable inside global addresses that can be used. You don't look at this and say, well, 228 is the network ID and 231 would be the broadcast address. So we only have 2 IPs, 229 and 230. Not when you're doing dynamic NAT, right? So remember that. And again, that is one of the more confusing things for learners, and I get a lot of questions on that. So definitely remember that. And we can go ahead and blitz that command right there because we've got the command in we need. So the pool has been created. So we now have our pool of inside, and here it's not, there we go. It wouldn't let me back over that last part there. All right, so we now have our pool of inside global addresses that are available for translation. Now, we only have 2. And so let's touch on this again. If PC1 and PC2 are the first 2 PCs of the day, right? So the IT workers show up early and they jump on PC1 and PC2 and they're going out here to server 1 on the internet. They will chew up these 2 inside global addresses. And then when your CEO on his laptop shows up and plugs in at his desk, tries to get out to monster.com or wherever, Facebook, whatever he's doing or she's doing, they are not going to get a NAT translation because PC1 and PC2 are using those. And that's a question we've got that's going to be, that's going to be coming up here shortly. So again, I wanted to cover the semantics of this because this is critical. Now, notice in the topology, we've got 3 network addresses that could be translated based on our ACL. What happens if more than 2 attempt to access the internet? That third one is going to wait. The default timeout period, once PC1 and PC2 connect out here to server 2 on real Cisco iOS, is 86,400 seconds. That's equivalent to 24 hours, right? That's the timeout. That's how long router 2 is going to wait before it purges the NAT translations in the translation table that PC1 and PC2 have. So your CEO is now locked out. Now, you could do a clear IP NAT translations with the asterisk, as we've seen in previous activities, or you could increase the size of the NAT pool so that it has at least as many IPs inside global IPs as there could be inside local IPs. Again, inside local, RFC 1918, inside global, those publicly routable IPs that are not in that RFC 1918 range. And so that's the answer for the question there. Now, this is probably the trickiest of the commands here. It always trips up learners, especially when they don't have something to refer to. So we've created the ACL, we've created the NAT pool. Now we need to bind those 2 entities together on router 2 so that when router 2 receives a packet that is, I was going to say worthy of translation. That's not the right word. That is eligible for translation. There's the word. It's eligible for translation. That it does that translation, but it refers to the ACL to figure out not only the pool that is involved, but also the range of inside local addresses that are allowed access to that pool of inside global addresses. So let's pull router 2 up here, and we're going to go ahead and map this out. So it's IP NAT inside source list, and list is nothing more than the ACL. It could be a named ACL. It could be a numbered ACL. And so we used number 1. So IP NAT inside source list 1. And if you think about that, if you thought of the English translation there, right? The IP NATing inside source IPs that are in this ACL list are going to be available to use pool NAT underscore pool. They're eligible for translation, right? IP NAT inside source list 1 pool NAT underscore pool. And you can see our percentage jumped up to 70% there. And I have a feeling here that we're going to get 15% on each of the IP NAT inside outside statements that we're going to be applying here. And so now comes probably the easiest part, which is we simply say do show IP interface brief, and we determine which interface is the outside interface that is not facing our network, and that is going to be this 209.165.200.225. And so we would simply say IP NAT, I'm sorry, we got to get into interface serial 000, IP NAT outside. Right, and that jumps us to 85%, so we did get 15 points. Now we go into the other serial interface, and we say IP NAT inside, right? This is the inside interface where I'm going to be checking IP NATing on the inside interface that are addresses in that source list, ACL list, are eligible for NAT translation using pool NAT pool. And that's exactly what that command says right there. You can see we're at 100%, but let's do some testing here. So I'm going to pull up PC. Oops, sorry, I didn't want to do the config. I wanted the desktop. So we'll pull PC1 up here. And I'm going to see if we can get the -T flag here. So if I say ping-T, let's see if that works. 165.201.5. And hopefully this is going to work. That -T flag right there tells ping not to stop. Because typically on these hosts here, we're going to get 4 pings and that's it. And then the ping stops. I don't want it to stop. I want it to continue in perpetuity, right? Forever while we're sitting here talking about this. Let's do the same thing here on PC2. Let's kick off a ping command using that -T flag. So we'll say ping -T 209.165.201.5. And so when we click on PC1, you can see the pings are working great. We click on PC2, the pings are working great. So now let's come back over here to router number 2. Let's go ahead and do a write mem. And let's say show IP NAT translations. And we should see lots and lots of translations. Now, the reason I use the -T flag is the following. Let's come up to laptop 1. Now, remember, both IPs, both inside global IPs that are being used in the NAT translation are currently locked up with PC1 and PC2. So what is going to be the response when I try to ping, and we'll just keep it without the -T, 165.201.5, what's going to be the response here? And I'm hoping that Packet Tracer is going to play nice and do what it is supposed to do, and that is not translate this request, because both addresses that are available, both inside global addresses available for translation, are locked up for the next 24 hours. That is the default timeout, 86,400 seconds, by PC1 and PC2. What if I came back out here and they wanted us to go to http:// and I just did the ping command there, 201.5. Can I get anything? I'll click go. I'm not getting anything, right? And this proves that we are going to be denied translation. Oh, sorry, pointed at router 1 there by mistake. And there you go, request timeout. Router 2 has no more addresses that it can allocate. So we are game over right there, right? All right, well, that is going to wrap up. What do they? One more command here. I think they wanted us to do. If I was to say, show IP NAT statistics is another one that we could use. And you can see here we've got the pool, and it looks like it's showing total of 2 addresses, allocated 1. We know that it's both because it's using 229 and 230. So we see our range there. We've got our Netmask. We get the access list that's being referred to. We can see the hits and the misses, the inside IP NAT outside interface, IP NAT inside interface. And so we've got a lot of information here that we're able to gather up. All right, well, that is going to do it for, and let me clear the screen here, for Packet Tracer Activity 6.5.6, where we took a look at how to configure Dynamic NAT. Again, remember, when you're creating that NAT pool with the IP NAT pool, and then we called ours NAT_pool, when you put that address range in there, based off the Netmask value, iOS is going to do a quick little check behind the scenes to make sure that the range of addresses that you have indicated all fall in that subnet range. And remember, your starting IP, if it would be the subnet ID, and the ending IP, even if it's the broadcast address, because we're talking about NAT, those IPs are eligible and are going to be reserved for use as inside global translatable addresses that can be used, right? So don't think that because you put in .228 and 231 that it's going to say, oh, well, that's the subnet ID and the broadcast address. We can't use those. I can only use 229 and 230. No, with NAT, it's going to use every address that you have indicated, start and finish, in that subnet mask range that you've indicated. Remember, it's not subnetting like when we put we're creating a subnet segment off a router interface. That is not what is happening when we're doing NAT. All right, again, thank you so much for watching. All the best to you in your studies, and I hope to see you in the next video.